0 plus 0 minus 4, is that going to be greater than 0? No, 0 plus 0 minus 4 is negative 4. That's not greater than 0. So in that middle section there, we've got a false statement. Okay, so that's not going to be included in our solution set. And then lastly, we can pick a number greater than 1. Let's just pick the number 2, for example. 2 squared is 4. 2 times 3 is 6. 4 and 6 makes 10, minus 4 is 6, which is greater than 0. So we get a true statement there. So with just a quick little sort of plug and chug of arithmetic in each of these cases, we have tested out the partitioned number line, and we've determined, hey, this looks good, this does not, and this looks good. So the question then becomes, how do I go about expressing my solution set? Like, how would I go about describing the set of numbers that make a true statement? Well, you can do it 2 ways. You could do it with inequalities, or you could do it with interval notation. Okay, we've practiced doing both. Oh, by the way, I failed to mention, does the number -4 or the number +1 give me a true statement or a false statement? Why? It's strictly greater than. So in other words, if I plugged in the number -4, -4 squared is 16, -4 times 3 is -12, 16 minus 12 minus 4 equals 0. Is 0 greater than 0? No, it is not. So we will not include these points because that's not an inclusive inequality. It's a strictly greater than. It's an exclusive inequality. So as I was saying, here's what we would do. We would say x must be less than -4. X must be greater than 1. And what word should I put in the middle? And or? We're going to put an or in the middle. Good. Graphically speaking, here's what that would look like. Right? So graphically speaking, we would be dealing with this kind of picture. And that solves for us that quadratic inequality. Because we found the quote roots, we partitioned our number line accordingly, and then we picked some test values to see if we get true statements in those regions. All right. If I wanted to use interval notation, what that would be would -infinity to -4, 1 to +infinity, and then remember our or symbol is that union of those two sets. So that's your interval notation. Okay. And there is a little bit more of a convoluted way of looking at this, and not that I want you guys to approach it in this manner, but it is a good exercise for us. So at this point, what we're going to do is I'm going to sort of pause and say, pause on this example and ask the question, what would it look like if I said A times B is greater than 0? So James told us something that is greater than 0 is something that is positive. So now I've just got an arbitrary or a general product that's greater than 0. In other words, 2 things being multiplied and the result is positive. How can that be regarding those 2 things? They must either have the same sign being positive or the same sign both being negative, right? So like, for example, 7 times 5 is 35. -7 times -5 is 35. Okay, so I can multiply 2 factors together, and if I want my result to be positive, they have to have the same sign, in other words. Okay, so what I'm looking at really is saying A has to be positive, and at the same time, B has to be positive, or A has to be negative, and at the same time, B has to be negative. Does that logically make sense, what we've got in orange there? That in order for a product of 2 things, whatever A and B are, in order for a product to be positive, they have to have the same sign. So it's both are positive or both are negative. Conversely, what would it look like over here in green if I wanted a product to be negative? They're going to have what? Different signs. Good. So maybe A is positive, and therefore what? B would have to be negative. Now, brown cow. Or vice versa, A would need to be, all right, and B would have to be positive. Are you smelling what I'm stepping in here? Okay. So like what we can do is we can use compound inequalities and we can sort of logically think our way through the process. I want you guys to become logical thinkers more so, because next year in your honors geometry class, whenever you guys take, Mr. Perry's class, part of that class is learning to think logically. And I don't have any sort of examples written up here. This is just a generalization of some basic logic of how two things could multiply and either be greater than zero or less than zero, right? What have we learned this year about two things that multiply to equal zero? What have you and I talked about? It's louder. Yeah, the ZPP says that A equals zero, dot, dot, dot. Oh my goodness, have y'all forgotten your ZPP? A equals zero or B equals zero. Duh. Okay, we've only done that about 1,000,000 times. So like you and I have talked about this down here at the bottom. Oops, I didn't get all of it. You and I have talked about this down here at the bottom as our zero product property, right? In black. Well, up at the top in orange and in green, those are both sort of extensions of that thought process. The ZPP is just much easier because it's an equation and not an inequality. Okay? So what I would like to do now is I would like to revisit this problem in blue, but I want to look at it through the eyes of what we've got going over here in terms of orange. In other words, can we write up this problem over here using inequalities? Okay, what would my quote A be in this case, Andrew? How about just x plus 4, right? So we're going to say x plus 4 is greater than 0, and x minus 1 is greater than 0. So in other words, both factors have to be positive, or what, Lewis? Yeah, so or x plus 4 is less than 0, and at the same time x minus 1 is less than 0. Okay? Now we can do, as Andrew, I think, was doing, we can subtract 4 and we can add 1 to both sides. Let's go ahead and do that. 1, 2, 3, 4. Let's do that all 4 times. So what do we end up with? We end up with x is greater than -4, and x is greater than +1. Down here, x is less than -4, and x is less than +1. Now, what would that look like on a number line? Here's -4, and here's 1. Greater than means I shade Nate which direction? Greater than means shade to the right. So we got greater than -4. Over here, I've got x is greater than +1, and it's an and statement. You guys remember from your talks with me about inequalities, what and statements require? They require both. If I say today I am going to teach math and I'm going to play baseball or coach baseball, then I'm going to have to do both for that statement to be true. If I say today I'm going to teach math or I'm going to go play golf back in Oakland, right? As long as I do at least one, I'm fine. But I can't say and then not do both of them. So in other words, this right here, shaded region, doubly shaded region, that's part of my solution set. And then down here, we could do the same thing. Here's our graph partitioned, -4 and 1. X is less than -4. X is less than +1. It's an and statement, so that requires both. Now, overall, it's an or, so I'm taking this first graph or this second graph, which means I can put them both together. And what will I end up with? That's not a coincidence. So we're saying numbers that are greater than 1 or numbers that are less than -4. And that's precisely what we've said over here. So we're logically thinking through why a quadratic inequality would look this way, okay? Now, somebody in the freshman class yesterday, I taught them this lesson yesterday, and they said, Coach Morgan, there's got to be an easier way. This seems rather convoluted. And I said, you're totally right. You're absolutely right, okay? If you go back, let me zoom out here. If you go back to the original setup, what we've just done is part A. We've just done some algebra, and we've been talking about the number line and really sort of thinking our way through the logical progression of using inequalities. It is much easier. I prefer, considering part B here, considering what the graph would look like on the XY plane, okay? Grove, what type of inequality are we dealing with in this example? Like what's the nature of x squared plus 3x greater than 4?
Quadratic.
It is a quadratic inequality. And Ben Rouse, what is the graph of a quadratic function? It is a parabola. So what we want to do for part B, we'll do it in red. What we want to do for part B is we want to consider y equals x squared plus 3x minus 4. We want to consider that parabola because technically what we're looking at is we're looking at this inequality right here, and we're going to do so by graphing it out, okay? So we already know what the answer is, but we're going to solve it again a second way just by looking at graphing it out. I think you'll like this approach much better. All right, so we have identified it. Grove says it's quadratic. Ben says it is, the shape is a parabola, and Joey's going to tell us the orientation of that parabola. You said field goal? Concave up. Good. Concave down will be swirl patrol. Again, these are not technical terms. Don't go to your teacher at your middle school and she asks you like, okay, talk to me about this parabola, and you're like, swirl patrol! She's not going to go for that, okay? Although I would know exactly what you're talking about. So this one's concave up, right? We agree? Right? Where is the zero? Where are the zeros of this parabola? In other words, where are its x-intercepts? Jack? Yeah, we already determined 1 and -4. So we did the legwork on that already. So check this out. Look, I've already got 1, 2, 3, 4. Already got a pretty good idea. What is the y-intercept of this parabola? -4. Good. We got that from just plugging in x equals 0. 1, 2, 3, 4. And you know, that's a pretty decent looking parabola. There's its axis of symmetry for those of you that like that kind of thing. I don't really care where the vertex is at this point. No pun intended. All I want is the general sort of the nuts and bolts of what this graph looks like. Okay. Now, I'm about to ask you a question, and this question might seem strange. It goes back to James's point about being greater than 0. What we're looking for right now is we're looking for where this parabola is, quote, greater than 0 or, quote, positive. Graphically speaking, what does it mean for our curve to be, quote, positive? What would be another way of saying my curve is positive on this particular part of the graph? What does it mean for a function's curve to be positive? First of all, what does a function's value have to do with, x or y? Yeah. The output of a function has to do with the y value. So another way of saying this is, where is y greater than 0? How would you describe the part of the parabola that is that has its y coordinates greater than 0? Grove?
Above the x-axis.
Precisely. Well done. What we're trying to determine when we have a quadratic expression that is set greater than 0 is we're trying to say, where is that curve above the x-axis? Okay. Now, how would I describe that? Well, I would say it's above the x-axis here and here. What are those x values? Everything that is less than 4 or everything that is greater than 1. Beard stroke, beard stroke, beard stroke. Where have we seen that before? We already knew the answer to this problem. Now that answer starts to make more sense graphically speaking with regards to the parabola. In other words, if I can see where the parabola, in this particular example, it happened to be greater than 0. If I can see where is this parabola above the x-axis, then I can, what the dump is OneNote doing? You guys see that? Restarted all of a sudden. Maybe it didn't like me poking the screen. If I can see where is it above the x-axis, then I can determine the solution set for our problem. See, what we're looking for is we're looking for all the x values that make this a true statement. In other words, we want to know what are all the x values that would make my y's greater than 0. And over here, we notice the curve is up above. All of these y coordinates of the points here on this graph are greater than 0. Same thing over here. So that's how we would describe our solution set. What if I wanted to change it? Okay. What if I wanted to change it and say, instead of greater than 0, what if I wanted to say less than 0? How would that adjust my solution set? Where is the curve now? Not above, below the x-axis. There you would say what? Oh, look, here the parabola is below the x-axis. How would you describe those x values? Preposition that starts with the letter B. Somebody said it. Between what and what? Between -4 and +1. So in that case, we would solve this equation out by saying, oh, x is between -4 and +1. Is that an or statement or is that an and statement? So that would be more in line over here with what we're looking at. I'll show you what that would be, just for dexterity's sake here. Supposing x squared, what was our original function to begin with? Plus 3 minus 4. All right, so write this down. X squared plus 3x minus 4, supposing that we want it to be less than 0. Okay. Quentin, you with us? So if I've got my factors like I normally do, so here this is x minus, or excuse me, plus 4 and x minus 1. All right, so now we're going to say, all right, if Coach Morgan wants this product to be less than 0, then that means each factor is going to have different signs. So let the first factor be positive, so x plus 4 is greater than 0. And let the second factor be negative, x minus 1 is less than 0. Or vice versa, so x plus 4 is less than 0, and x minus 1 is greater than 0. Okay, and then let's solve both of those out. This is compound inequality, good exam review question. Let's solve this out. Subtract 4, we got x has to be greater than -4, and x has to be less than +1. What does that look like graphically speaking? There's -4, there's +1, open and shade to the right, open and shade to the left. And requires both. That's the region where we shaded on both. All right, or we've got a secondary option here. Subtract 4, we got x is less than 4. And add 1, we got x is greater than 1. If I graph that out, there's -4, open shade to the left. There's +1, open shade to the right. Where are they both shaded on that number line? Nowhere. They're not shaded on that number line. So this part would be bogus. This part couldn't happen. It couldn't be that the first factor would be negative and the second factor would be positive. There is no such set of numbers that would satisfy both of those. Is that going to be a deal breaker? Does that mean that this has no solution? Of course not. Because what did I write in big fat capital letters right here? This is an or statement. And that means that at least one of these must be true, and oh, it just happens to be that one. And remember what we said graphically speaking, where is being less than 0 is equivalent to saying, oh, this parabola must be below the x-axis. Where is this parabola below the x-axis? We would say, oh, between -4 and +1. Now, I know what you're thinking. I know right now you're probably thinking, gee, this shortcut sure doesn't seem short. Okay, this shortcut seems tougher than what we did initially, over there. You got it in the blue box over there where we just, tested out 3 regions. True that. True that. But what this shortcut sort of graphing on the XY plane allows us to do is it allows us to deal with problems that are going to be more complicated than a simple quadratic, okay, inequality. Because the algebra will get a whole lot, heck of a lot harder if we don't have something simple that factors, right? So like what if I gave you a quadratic inequality and you weren't able to factor it and you weren't therefore able to sort of easily partition your number line up, you would be stuck, so to speak, or heaven forbid I give you like a degree 3 or degree 4 polynomial. Okay, so here's what we're going to wrap up class with. There's a nice, neat little example for you guys to try. And I want you to try to work it whatever way you'd like to, and then we'll discuss. Bossy. You know what, dadgummit, Mossy, you've reminded me, but you've reminded me half an hour into class. While you're working, I'll talk about it. Thank you so much. Let me freeze my screen here so I can pull up my calendar. There we go. I emailed a parent yesterday, and because the parent had been asking about, hey, what are exam plans looking like? And so like right now, Christian Brothers is out on May 26th. Christian Brothers is done on May 26th. And so I'm assuming you guys are done before then. And so I emailed her and I said, look, we'll have our exam on May 17th. That's a Monday. But again, I told her, I said, I'm not quite sure what like middle school calendars are looking like, so that might need to change. But right now I'm shooting for the 17th. So you guys need to tell me, when is y'all's last day of school? Do you know that, Luke? May 11th is your last day of school? So like, do y'all take exams like the 10th and the 11th, that kind of thing? Y'all don't do exams, okay? Read. Y'all get out on the 21st that week, okay? And then does anybody from Holy Rosary know their schedule? No, y'all get back to me, okay? Get back to me next week. Roll up in here and say, hey, coach, here's what it's looking like. All right, so if OLPH is out on before the 17th, I'm going to leave that 17th as our date for our exam, and then we'll say that perhaps is subject to change. I might bump it up. I might not. We'll see. So thank you, Mossy, again for reminding me of that. Ooh, that's hot. H-O-T hot. Does anybody have this one factored already? Jack, you got it factored? Candy Auto? Fabulous. By subtracting that 7 over to the other side, now this is less than 0. We got our product that's set less than 0. That means that I can partition my number line, right? there's going to be two partitions right there. One of them is at -7. One of them is at +1. Those are our two roots, right? Did you guys go the route of like pick a number over in this region and see if it's true? Pick a number in this region, see if it's true. Pick a number in that region, see if it's true. Anybody do that? All right. If you did not, then I'm assuming your alternative approach was to graph the parabola, which looks like that. Okay. Again, having the same two partitions, -7 and +1. What class? What's another way of saying less than 0? Negative, graphically speaking. Louder. Below the x-axis. So I can already tell the orange one is easier than the green one because the orange one wears the parabola below the x-axis. Between -7 and +1. So I could say x is between. Now, why am I not including 7 and -7 and 1? Because it's strictly less than, right? Okay. If I went over, so that's my answer, problem done. But if I went over here the green route and I was testing out some numbers, right, I'm going to get a false statement, I'm going to get a true statement, and I'm going to get a false statement. Okay. So in other words, I would include from -7 to +1. Jake.
Do you not have to draw a dot parabola with less than?
Great question. I do not. Because I don't care. The graph is not my answer. The graph helps me figure out my answer. Okay. Now, what you're thinking of is like in the context of, hey, what if we wanted to graph out y is, I don't know, let's say y is less than x squared plus 6x minus 7, right? In that case, that's where we would do the dotted graph, right? And we do the shading and all that jazz. But that's not what this question was asking. This question was saying, hey, there weren't two variables to start with, in other words. It wasn't saying, hey, come up with a set of ordered pairs that will make this true. It was a single variable quadratic inequality. So it was saying, hey, give me the set of x values that would make this true. Fabulous question there. Alex.
On the number line one, if you just test the middle and it's true, do you not have to test the other one?
Great idea. Great thought. Not necessarily. Sometimes, watch this, fellas, eyes up here. Sometimes you'll get a false, true, true. Sometimes you might get like a false, 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 no solution. Sometimes you might get a true, 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 or a true, true, false. It depends from problem to problem. So partitioning our number line up and then testing each section is the best way to go about doing it. All right. Hey, great class today. I know we worked on some hard stuff. We finished up chapter 9 today at the end of the week. Monday we'll start chapter 10, our last chapter of the year. So y'all head home and be safe, or head to school rather and be safe. Live Jesus in our hearts. All right. I appreciate you guys. Y'all take care. Thanks again, guys.